Welcome back to Meshmen Studio. So in today's episode, I want to talk about ACES in Mari. So let's dive into it now. Today's episode is gonna be quite a lengthy one, so I'm gonna link in the description different timestamps so you can jump around. Yeah, so in the last episode we took a look at how we can set up an OCIO profile for different programs, mainly RenderMan and Maya and Mari is to install like an environment variable, and I also went through some basic concepts around ACES in general. When I now have a project here, we can see here that yes, indeed I have a custom OCIO profile. So if you didn't watch that episode, there's gonna be a link in the description, and also now I'm gonna do a link here up in the corner. Okay, so I want to take a look at the different ways we can interact with colors here in Mari and Colorspaces. So the first obvious is to go to channels, because they have the most rules around them essentially. So one thing here to make a note of is the bit depth. For example, if I say that this 8-bit channel here, if I assign this to this statue here, let's see what happens. And I drag this up here, and we can see here that my color data here is set to Colorspace automatic utility sRGB texture. So when you create a channel in 8-bit format, it assumes that the data that you are putting into this is gonna be in sRGB texture. This is something you can work with. A lot of studios work in 8-bit, almost all data. Personally, I use 16-bit to essentially, I don't want to lose precision, because if you would project something here and export this out as an sRGB, you want to be careful about how you convert this into linear later on when you do that, because you might lose precision if you export something out and do MIP mapping before you actually convert it into linear. So that's one reason why I actually, when I work in ACES, I don't use 8-bit channels, but that's me. I use 16-bit channel to have the most flexibility. So 16-bit half is what I use when I use Acescg. And also when I create this now, let's see, 16-bit, assign this one now channel here, and take a look what the color space. Now you see here the color space is now automatic Acescg, and that's because my settings here on the color space 1632-bit float data is set to Mari float ACES Acescg. So this is the rule that this one picks up here when it gets this Acescg. When I created the 8-bit, it picked up this Mari int 8 utility sRGB texture. That's the rule that it picked up when I created 8-bit. The data now coming into my 16-bit channel is internal color space. Essentially, it's gonna be converted into Acescg, and that's the way I use Acescg. One thing here that could be interesting, when you export something, you also have, if I go to export current channel flattened, you have the option to actually override the color space. So you can say, okay, this channel here is 16-bit, so it's gonna be exported as Acescg, but you could essentially override this to be something else, output sRGB or any type of utility sRGB. It's gonna convert it, but what I do when I use my Acescg is so create 16-bit channels, export everything out as Acescg, and that's the way I maintain the best possible quality in my textures, because then if I have import an 8-bit image, it's gonna be projected into something that's higher than its own bit depth, so you don't lose precision that way. Otherwise, you're essentially limiting your textures on a channel basis. So let's take a look here now at the same goes to if I create a paint in the node graph. In the node graph we have, it's a bit more of a manual. Let's take a look at this 16-bit channel here, and let's go to, where is it? You see here, it's already set up by the channel rules here. If I create something from scratch in the node graph, you don't have this channel to dictate how the color is really managed, because then you're building it from scratch. So you have to have a bit more oversight in when you build something in a node graph. For example, let's take a look here. If I create a paint node, so here, I have P here, you see you have the option here to create different bit depth here as well on a paint node basis. So let's say that you have a 16-bit, and here in my node properties you can see here that it has the Colorspace rule, a automatic Acescg. That's the same as this one would have, but this one is essentially controlled by the channel. But in this example, I don't have any channels, so this is a loose node. It's like it doesn't contain anything that's governed by something else. It's just on its own. So if you would create two different channels, for example, you create one channel that's 8-bit, and then you create another channel that's 16-bit. And you see here, I can route this to two inputs. So therefore, it's gonna be, in this scenario, it's gonna be really hard for it to understand, to kind of dictate from a channel perspective what this node does, because you have built this yourself and you have essentially mixed it into two different channels. So this is, I guess, both good and bad. So there's a few scenarios where Colorspace is crucial when you blend values using a node graph. Okay, so I want to take a look at different color settings regarding channels now. So 8-bit, let's create one of those. Just keep it as simple here as possible, and let's create this one and take a look what we get. So there we have it, 8-bit, and we can see here it's an sRGB texture. Let's take a look here at my advanced blending. So that's something that we can go into this green arrow here and take a look at. You see here, Colorspace enabled. So this is something, this is a bit hidden when it comes to channels, because it's something that you normally don't interact with in the channel workflow. Not that often, at least. Let's take a look at, if I now create another 8-bit channel using, but this one is gonna be a roughness channel, 8-bit rough, just to differentiate between those two there. And to make a roughness channel, it's a scalar data. So let's see here what, when I set scalar here, the Colorspace here, you see it's automatic utility raw is something that it sets to. And now here we can see here utility raw, and let's take a look at what this green arrow now have here. So you can see here now it's disabled. So what's this all about? And let's say that you want to blend, for example, a bump, and let's say that the bump is 0.5 in its base, and you want to use the blending mode overlay, for example. So let's create here using a gray constant, and we want to use overlay. Let's see, I want to blend here. I don't want to see any visual difference when I add my gray color, because when you have overlay, 50% gray should essentially do nothing. So if I would instead use a paint node here, let's say that I create a layer and I select all my patches, select and fill with gray, paint something with white and dark, and I set this blending mode to overlay, contrast, overlay. Now when I tone this down here to 0, nothing happens, but you see the gray value stays the same. And this is something that's the blending mode here set to disabled here is for the 8-bit data. So let's take a look here what if I do the same here now on a 16-bit channel. Let's set this one scalar 16-bit just to be sure here that everything is fine and dandy. So when I set scalar, it turns off Colorspace on the node there, on the layer. So let's take a look here, same bit, disabled. So the problem is essentially when you build this in the node graph, you have to have a bit more oversight what you do there. So let's delete this. I can show you the problem when you build it in the node graph, similar approaches. So you use, this is especially evident when you use scalar channels or scalar data in general in the node graph. You want to manage a bit more your merge nodes color space. So let's create a example where I use a gray constant. So that's just a 50% gray value. Let's create 2 of those, create a merge node and pipe 1 into the base and 1 to the over. Set the blending mode to, first take normal so we can see when I blend this now, should be visually no difference. Let's now set this to overlay. You can see now it popped there, it got brighter. So this is a bit of a problem when you blend scalar values or bump maps or displacement, because every time you add an overlay with the 50% gray, you're gonna get brighter. So you can see here, when I create a merge node in the node graph, you see that the merge node defaults to Colorspace enabled. And this is something you want to set it to disabled there to get the same appearance as when you create a channel. So when you create a channel and set the channel to be scalar, it sets this Colorspace enabled for all the layers essentially, and it's governed by the channel. But as we now create the merge node on its own, it doesn't have a channel to dictate that you have to set this to disable. So that's a caveat when you work with scalar data. There's a few blending modes, for example overlay, and also when you blend normal maps, it's one of these that you want to set this to disabled as well. So let's demonstrate that quickly. Let's set this to just create 2 tiled nodes like this, this one, and whoops, yeah, we can have this one as a tile. Set this to 2 so we have a different pattern, base and over. Let's zoom in here, we can see what's going on. We can see that I have 2 normals there, and to visualize the normal map properly, as it's a merge node here and it's living on its own, the LUT here doesn't really know that it should turn off color management there. So you can just disable it. So now this is the true normal data there. If you want to blend 2 normal maps together, what I usually use is the normal maps mix reorient. And you can see here, if I set, you see here, when I set this amount to 1 here, this looks nothing like a normal map when I mix reorient. But if I turn the Colorspace enabled to disable there on the merge node, they will look properly. And you can see here now the extra detail is added and the normal map behaves correctly. So blending overlays and normal maps is some of the instances when you want to use Colorspace enabled here, this setting on the merge node, but set it to disabled, because essentially you are working with linear data and you don't want to apply sRGB or a LUT on top. So I believe what this Colorspace enabled is routing back to is a way to mimic what Photoshop actually did on overlays. And Photoshop traditionally came from, low bit depth. So to actually blend some of these blending modes, they applied a LUT or like a Colorspace conversion on top of the image or the blending mode itself. So I think something in that term, this is why. But now when we have already linear values, you need to turn this off, because otherwise you get unpredictable result. And that's essentially when you work with scalar values, it's really important. Or bump maps, displacements, normal maps, all of this. Maybe if you have a roughness channel and you wanna treat it with an overlay, then definitely if you use the node graph, turn off Colorspace to disabled. Okay, so I want to take a look at how we can import different media into Mari, mainly set the different color rules. And I'm gonna now project a image onto different color spaces. So let's now take some color charts and project here so we can see why it's important to know what color space. So this is something we mentioned in the last episode when we import something in linear Acescg and another color space that might be sRGB color space. So we can take a look at different ways to import. So that's the first thing here. Okay, so on GitHub, I'm gonna supply the link also in the description from this page here. Let's download some of these here. So first off, sRGB color checker here. It's an EXR, so it's an 16-bit. We want this guy here. So let's see, download, and let's go back and find CG color checker. So let's import these. Let's first import the ACES one and project it on top of this one here. Let's go to my image manager. Okay, so I place them here on my desktop. Let's go desktop, ACES. So let's first take this ACES one here, and you can see here automatic ACES. Acescg, remove any alphas if there is, but I don't think there is. And see here, so here's my ACES color checker. So we did this the last time. Okay, so I'm looking here at flat shaded, and we can see here, using my color management, I'm looking through an ACES sRGB LUT, turning this off. This is the linear representation of ACES. Let's now create a layer here onto my channel here. So let's just create another one. And now let's import this sRGB. So the sRGB one is a linearized because it's an EXR. So in the same fashion, it's a linearized sRGB. So you will see that we will get some differences if I import it in this way. Actually, let's take this one here, and don't want to move this now. So I'm gonna reproject it onto the base layer there. And now we want to take the sRGB here, and as you can see, it will say automatic ACES. So let's see what happens when I just let this take care of this. The thing is, when I downloaded this, they are both EXRs, so we will see if there's going to be a difference. And we can already see here onto the preview that something funky is going to happen, and that's something I want to explain. So we have to have an eye onto this. So let's take this layer one, linear sRGB, because this image that I downloaded is a linear sRGB, linearized sRGB. So it's important when you import something that you dictate the correct color space. So we can see here now, if I take my image here and just drag it on here, you can see here that the colors here, they go super funky here. So let's stamp this down and bake it, and we can enable and disable this layer so we can see the difference. And you're gonna see there's a big difference there. Take this one, you can see here that it just goes totally bonkers, because when I imported this, Mari assumes that this EXR image is also ACES, but they have different color spaces. Let's now actually import this correctly. If I now import this one again and say here, when it says automatic ACES, this one is not an ACES linearized. So it's in a utility. We need to find utility, linear sRGB. Where is it? Linear sRGB. So this one is the correct way to import something that's a linearized sRGB. We open it, you can see here, and now we can even on the preview, you can see that they are kind of looking the same there. So let's drag this on, damp this down, and bake it again. So let's go in here now, and let's take my image, my layer here, and you can see there is no visual difference. So now the color management was handled by me importing this Macbeth chart here in the correct color space. So I told it that this image comes from an linearized sRGB color space. This was me importing it because it's an EXR. Mari, looking at this color space rule here, let's see, settings, 1632-bit, it's gonna assume that it's an Acescg, but this image was actually encoded in linearized sRGB. So that's why you get this difference. This is difference between the two color spaces. You can see here that's applied because we imported incorrectly. So that's something you have to take a look at. But in most cases, when I work, I'm pre-converting everything that's 16-bit EXR into ACES. If I use a JPEG image, I'm assuming that's in sRGB, or like 99% of all JPEG images is sRGB, and then I import it using the utility sRGB texture instead. And that's something we looked at earlier in the last episode. So in this chapter, I want to take a look at how we can import Megascan images into Mari and how we can apply different color settings for the different images. I just opened here my library Quixel, the Megascan bridge here. So let's go to surfaces, find something that we want to test out. Let's take some concrete so we can apply here onto my statue. Concrete floor. So let's download it. See here what happens when I import it into Mari. Okay, so it's downloaded. Let's go here and right click and go to files and see where they are. Let's take a look here what I have. So albedo here, for example, if I look at it, this is the textures that comes here. And we were gonna import some of these here and use them in Mari. So first take a look here at my albedo here. It's a JPEG. I have the intermediate version, I think, because if you have there is one where you can actually download EXRs. Let's see, download settings, do I have that? So in some accounts, if you buy the one with that's the advanced one, you can choose between JPEG and actually EXRs, and I'm assuming the EXRs would be linearized. In my case here now, let's go here back here to the files here to take a look. For example, the albedo JPEG here in let's go here and copy this address and go back to Mari. Let's switch over to my object, hide this one, go to my statue. We want to import this image here, so let's create a new tab. Take a look here. Let's go to this location, albedo JPEG here, and you can see here it says utility sRGB texture, and that's essentially what I want because it's in a JPEG. Let's do this. Let's create a RenderMan shader first. Let's take the pixel surface and let's create the channels using the shader, the RenderMan menu instead, so we can hook it up. Create add channels, diffuse channel. Then we want, let's take physical specular channel. The channels, let's frame these as well. Let's go to my shader. So I want to have normal map. So this one in the RenderMan menu, you don't have that. You can add, I'm gonna do that in another tutorial, how to add custom channels to this menu here. I haven't done it. So let's see here, normal, I can just hit this one here and say normal, if I can spell. We want this to be scalar data and hit this one. There we go. So yeah, let's see here if I import other images. We have this one sRGB. Let's take a look here. So the normal map, for example, we can see here normal here, as it's a JPEG image, this is gonna be imported as utility sRGB texture, and that's something I don't want because the normal map, if we go back to the files and take a look, this is the colors that normal map requires. It's essentially data-driven channel, so we don't want to apply any color management this one. We want this image because in sRGB image, but it's still representation data values. We want to import this as raw data, so we are bypassing any color management. So we're essentially just taking whatever values we have in this file and importing them straight without any color management. So that's something we want to achieve. So let's go back to Mari. So normal here, we want to import as, or we can take role let's see, scene, we should have reference utility raw. We want anything with called raw. And let's import that one and see that it comes in. And we want to set this to, we can set it to raw data and scalar here as well. Let's see here. So let's actually go here to my channel, go to my normal map, just export, just project this down here, and let's say repeat, stamp, bake it. See here, yeah, the values here now when this is set to raw. If I compare, they should look kind of the same there. So let's just bake this down and take the other one. Yeah. So that's the normal map. You want to import it as a raw. I also just tick the scalar and raw just to be sure. So looking here at also as another one that we can do similar things with, the specular roughness, for example. That's also a data-driven channel. So let's take a look here. Specular roughness. So this one, you don't wanna have a utility SIB texture in this one. You can also import this one as raw. So let's go to input, because it's a JPEG, but it's essentially a scalar value as well. Take a look here. We can actually create a image array and start to populate these images here. So we want to have in image A, we want to have this color map. And this one, let's set this to scalar here as well. Can the roughness, and let's take the normal map here on image C. So now we have output. If I go to this one here, take a look here, we should have an image array coming with my color map, my specular roughness, and my normal map is input C there. So let's take a look here. This one is not, I have to turn off color management to get this to work properly there, because it doesn't know what color management, it just have color management on there essentially, but that's just on the null level. So let's hook this up to some of the places here. It's like a manifold UV, something like this. Take this one to the color there, and then we want to have specular roughness. It's gonna be going in here. Let's see, specular roughness there. This, the last one here, is gonna be the normal map. This one, normal color. I'm just gonna be putting a normal color into the base there, so we know. And let's take a look here through the shader. So we need an HDR. So let's take lights, Luxor Junior under the random menu. Do they ever have something? Okay, so it's quite common that you get pre-converted images that's already in ACES. So let's take a look at some of the workflows here as well. Here in Nuke, it's the easiest to do this. If I go here to hit the S button, my color management here is set to OCIO. So this is the working space scene linear is Acescg here using my config. So what I've done here is to take here my, if I look here at this image here, you can see here that this image, the same that I imported into Mari here in Nuke, now have Mari int 8 utility SIB texture that I swapped this to, because this one is an 8-bit image. And this one, the normal here, you see here, I switched it to raw data. Essentially what I did also in when I imported into Mari, specular roughness, the same raw data. And because this one is non-commercial, I have to reformat this down now to something smaller than the HD, to 1024, 1024, and then I just export them out as EXRs. So they're gonna be linearized. So let's take a look at what I get. So this one is gonna be linearized into Acescg using the Colorspace rule here, working space in linear. So that's what I want. This one is gonna be looking like this if I apply LUT, but essentially it's raw data, so it's just bypassing the color management. Setting this to raw, you can see it's the same here, just the raw data from the normal map that are passing out here to Acescg linear. Same here for specular roughness. looking at it raw. If I would turn on ACES sRGB, you see then it applies a double LUTS, so I don't want that. I just want the levels coming in here from the raw pixels. So I've saved those out into the same directory where I have the original JPEGs, and now switch over to Mari and import those as well. In my image manager, I made a folder called ACES here. So I want to import these EXRs here. So let's take a look. Albedo EXR, normal map EXR, and specular roughness EXR. You see that the color space is set to automatic ACES because they are EXRs. And my color space rule, as we remember, is picked up here by the settings. This one, Mari float Acescg. And when you import your images here into Mari, so this one, you don't have to say anything. If you wanna have something, a proper preview of this one, you have to set it to scalar data. So yes, what this one? So all of the images that's scalar or have scalar values, you wanna set to scalar data here in Colorspace rules on to the actual source images. So that will be the same as I did here when I imported JPEGs, but this one, you see it has a Colorspace rule setting to raw data there. So it's the same workflow essentially, but in some places you might have pre-converted into ACES your source library, or if you have this premium account, maybe you also have EXR images, and that's another way to do it. When working with colors and constant colors, sometimes we want to convert from one color space to the other. So we're talking about sRGB to ACES conversions, for example. So we have a color and a target color space in the color palette. So let's dissect some of the workflows here as well. I have my color palette here. And if you go to values here, taking a look here, we can see here that if I select one of my channels here, so let's take a look here at my color there. You can see here, first off, on the channel level here, you can see that you have a 16, so that identifies that this is a 16-bit channel. You can also see here that it has two icons there. One is color and one is like a black and white version. So one is meant to hold color data, and this one, the roughness one there, is a scalar because I set the color data here to be a scalar, so I tick this box here. So that's important when you take a look here at some of the values here. For example, if I go back to the color one here, you can see here, if I under my values palette, we see here two values. So one is sRGB and one is ACES. So this is important when you pick something, a color, for example, it's gonna convert it into ACES. So if you pick a color in sRGB here, it's gonna be auto-converted into the linear representation of this color in ACES. And that boils down to our OCIO profile that we looked at in an earlier episode. If I go here to the project settings, we can see here my OCIO config is specifying that my 1632-bit float data is Acescg. And if I use a 8-bit texture, for example, or 8-bit, then it's gonna be assuming that that is sRGB texture, and that's something we looked at, how we can import images. But this is also something if I would, for example, use a channel to hold scalar data. This you can see here, when the channel is set to scalar, you can see that the target and source is the same. So if I set something here using, let's say that I want to set the value here of 50%, and you see here my color slider here is essentially sRGB, but you see here it doesn't down convert to Acescg color space because it's a scalar data. You can see here if I untick the scalar here, you can see then my input color space here, that's the color space I use to choose the values, is then converted into the linear value. So it's linearizing the value there on the fly. So you essentially is a way to look at what value, if you would have an sRGB color, what it would be in Acescg. This is something I 9 times out of 10 I have this set to same as 8-bit data utility sRGB texture. There's times when I want to specify something. Well, let's say that I want to specify a vector value using like a constant node, for example. I might actually set this to become Acescg. Let's say that I want to set 2, 3, and 4 in values. This it becomes more like a vector rather than because now we are talking, this is Acescg is the linear values. So then I can set the linear values. So now let's take a look at some concepts when it comes to choosing colors in the node graph. It's a bit different because when I have a channel, the channel dictates some of the color space rules, and as we saw in earlier chapter, when I use the node graph, this is a bit more tricky because the channel is essentially guiding the nodes how they should treat colors. But when you build something in a node graph, it's something you have to be a bit more vigilant about yourself. So let's take a look at color. For example, if I have a color node here, let's take a look here, and you can see here on a node basis, when you have any type of input field for colors, you have this icon here if you want to specify a color or a scalar data. So let's say that you want to have a color, you want to set this to 50% gray, for example. You're looking at it and it looks nice. This is all handled now in the node graph. Let's take a channel node, say that call 3 or something, and there we have it. So sometimes when you switch from, if I would have 2 nodes here, if I switch from one to the other, you might experience some issues when it comes to how it displays the values here, because essentially I'm setting something here. Let's create another node here, and sometimes when you have a channel, it will turn on and off the LUT here. But when you set a scalar value using the node graph, this might not actually be true because it doesn't know that essentially what you have done here, because there's nothing governed. You see here, if I switch between this color, that's 50%, this one is a color 50%, this one is scalar 50%. You can see that essentially now this one goes a bit brighter, and that's because I'm actually looking at this scalar node but through an sRGB LUT, so it applies a LUT on top. When you have a channel, this is handled more elegantly by the channel, so that's something. But when I work with scalar data in the node graph, if I'm working on a bump map or a displacement, roughness, or any type of data that's scalar, I turn this color, the LUT here on the color, turn this off. Or you can actually also go here and set it to raw if you want to turn it off, because then you get actually the true values from the scalar data. So it's easier to actually visualize that. So that's a caveat, and that's because this one is a lost node. It doesn't know actually if I'm gonna use the LUT or not, and that's something that the channel node itself takes care of. Okay, so in this chapter, let's quickly go over LUTs and View Transform tab. So related to color management and ACES is the use of LUTs. So let's take a look at how we can interact with LUTs here in Mari. In the View Transform tab down here, you see this the bottom row here. We can see here the colored RGB wheel here, or kind of a color space icon. If you untick this, you turn off color management. You see here I have projected a plate onto a plane here. So I graded it using ACES in DaVinci Resolve and just imported the EXR into Mari, and so we have something to visualize the LUT here. So in production, you will most likely have a monitor that's color calibrated to a specific color space, and most monitors are some kind of Rec 709 LUT. That's the base of the monitor itself. So here in Mari, if I have set here using the color management, my OCIO here, monitor here defaults to sRGB, and looking at the LUTs here's the LUTs that's applied with the OCIO I have set here. So we have sRGB, that's the default. We can also look here at Rec 709, for example. It's a less contrasty lookup. What we see here is with the LUT applied, so the lookup table is applying the LUT. The true colors or whatever, the linear values, if I turn off color management, this is essentially what I've projected look like when I project it. So this one, you can see here, this is a linear image. You can see here it looks overblown and super saturated and really dark, and that's because when I turn off color management, we see here without a LUT. Turning it off on here, we can see here now a Rec 709. So some of the LUTs is very specific and have specific needs. And for example here, the D60 Sim, I don't have a monitor that capable of that. But if you would have a monitor, it might look a bit different. It's not that of a big difference actually, but when you work at the place, you will probably have, you know, some kind of neutral lookup table, like something like sRGB or a Rec 709, essentially just giving you a sane lookup when you texture. But when you work in shots or lighting, you might have a very specific lookup table for the plate or the movie, and that you might have something here in the list telling you, you know, like this and that movie show LUT or anything. So yeah, that's something that you might be exposed for. But in this vanilla OCIO profile, we have these LUTs here. This is the one that ships with Mari, if I use the Mari default one. And also here, looking at setting this back, slightly related to that is we can look at individual channels. We can look at red, green, blue, for example, luminance, RGB. And also here we can overdrive, for example. We can use exposure or gamma. So this is exposure, this slider here. This is for more for QC and these purposes, maybe gamma. So what I use these for, the exposure and gamma, is mainly to check my textures. Let's say that I want to check if I have something that's super black. Let's project something here, because you don't want something that's pure black. If I would take this color here, the pure black there, and paint, you see here, you don't want something that's just black, because that one will always, you will never be able to expose it up like I did here. You can see here, you know, my plate is, you know, super over exposed, but where I painted here, it's still doesn't react because it's just 1 or 0, I mean, and that's something that's usually bad when you have a texture. You want something that's slightly above so you can expose it up in texturing. So you will have different diffuse values, albedo values that you want to target in your textures. So that's a good way to see that you don't have anything that's pure black. Just expose it up and crank up the gamma or whatever you want to do, just to see that you don't have these values hanging around in your textures. And also when I work in painting maps, for example, let's say that you in the node graph, let's say that you want to paint a mask, you want to check it. Let's say that you have a scalar channel and you paint an ISO and like a mask that you want to drive something with, and you're not sure if you have something that's like you painting something with a very small value, and you not really sure how it looks like, it could be good to just over crank it a bit so you can see where your values actually end, so to speak. So yeah, that's another way I use it. I use these mainly to as a QC tool, or a way to interact with your paint. So let's wrap this now and export some of the material that we applied onto the model. Okay, so I'm gonna project this color checker here. That's an Acescg color checker onto different channels and color spaces. So 16-bit here, it's gonna be Acescg. We're gonna have an 8-bit as well here. I wanna test that. And this one is also an 8-bit, but I'm gonna export it out, this one out in Acescg instead of the default one, so we can see what happens when we do that. So when I work in Acescg, I extensively use 16-bit channels, at least for everything that has color and high definition. Sometimes I actually scale out channels like masks and stuff. I actually use 8-bit because, yeah, depending on the need, but color sensitive stuff, definitely working in 16-bit. So let's take this Acescg color checker here and just stamp it onto here, my 16-bit, and bake it down. Then I'm gonna swap channel here and bake it to my 8-bit as well. Same this one, like a plate or something too, so we can see what happens. 16-bit. So this one is imported as Acescg because I graded it as an EXR from DaVinci Resolve. I captured this on my Blackmagic. Let's stamp this down. Just do the same here. Let's take something from my statue. So this one is an sRGB texture, you see here, imported using the automatic utility. So let's do that. Take it down here somewhere. So we have some different scenarios here. So now I want to export all of these out and see what happens when I open them in Nuke. So if I go over 16-bit channel, say export current channel flattened, we see here what we get. Let's go one up here and take this one with the color space that it's assuming that we have created, and that's correct, Acescg. So this is the color space that this channel will export. You can override it, but yeah, when I use ACES, I use 16-bit channels and they are automatically exported out as Acescg. So let's say export all patches, 16-bit. Now let's take my 8-bit channel, just take 8-bit on this one, name, and you see here color space, same as utility sRGB texture. So this is the color space rule that we have talked about earlier. 8-bit channels is assuming, you can see here, color space, this is what it is using. So I'll export this out as default, and now take this one, and this one I'm gonna override, ACES, 8-bit ACES, I wanna call this one, because what I'm gonna do here is to see here the color space, I wanna set this to same as working Acescg and see what happens. Okay, so there we have it. We have exported this one in Acescg, this one as default 8-bit automatic utility sRGB texture, and this one that when I name it 8-bit ACES, I actually override it to Acescg. So let's now open these in Nuke. Okay, so here in Nuke, let's read in the images. So let's take these 3 here that we exported, ACES, and take a look. So first off, I wanna set all of these images to raw, so we can see the raw value. So I set raw here, and just to see what was exported out from Mari, so we can see here. I wanna set this one to raw here, my LUT, so I essentially turning off a LUT, and take a look. So let's see here, 16-bit, we can see here, this is what was exported out from Mari, and we can see here it looks kind of dark and saturated. So this one tells me it's a linear image. This is not, it doesn't have the LUT applied to it. This one here is the 8-bit. Looking at this one, you can see here, this one actually looks like when we projected it in Mari. So it does have the sRGB LUT applied when we exported it. So remember, the 8-bit channel, when we exported it, it said 8-bit utility sRGB texture. So that's why it has burnt this LUT into the image when we exported it. This one was the 8-bit that I named ACES. And remember, this one, when I exported it, I overread the color space on export to be Acescg, the internal working color. So that's why this one is an 8-bit channel, but it will have the same color gamut, the ACES color space, burnt into it, or essentially linearized into Acescg. So yeah, you can work 8-bit channels and export out as Acescg. However, when I work with color sensitive data, and let's say that I have a texture that's coming from a internet or something that's 8-bit already, projecting it onto a channel that's the same bit depth as itself is generally not a good thing. That's why I prefer to use 16-bit, because at least I can capture, I don't get a degradation yet again when I export, project something onto the channel. So that's why I myself see myself working in 16-bit channels when I'm working Acescg, except some caveats when I say, for example, like channels like masks and stuff, or black and white stuff. 8-bit is really works really well there. But yeah, anything with color sensitive data, I use 16-bit. So looking at these two, you can virtually see very little difference, I would say. You can see a bit there. You can see here that essentially this one, yeah, you can see if I would expose this down here, you can see the banding in the 8-bit versus the 16-bit. That's probably, let's set this to sRGB, go between, you can see a bit. Yeah, so it definitely works to work in ACES using 8-bit. I prefer to use 16-bit because I feel more comfortable that I capture all of the nuances. And also one thing as well, what you want to do, you want to have the MIP mapping. So for example, when you do render stuff in RenderMan, for example, you have a special format called TX files. You want to do the color conversions before MIP mapping. So that's why it's better to actually export it in linear before you do the MIP mapping. And yeah, that concludes this look into the different Mari, Colorspace, ACES, workflow and tools, etc. for this time. And in the next one, we're gonna take some Mari projects into RenderMan and see what we can do with ACES in RenderMan. So stay tuned for that and see you on the channel. Bye bye!